Hello, I'm Ridae, a master's course of DTMNet, and I'm going to review the paper today. First, the bibliography information of the paper. The paper was published in the journal TFSC in November 2024, and the keywords and highlights of the paper are as follows. The table of contents is the same as the table of contents of the paper. First, the research background and necessary. Recently, as the life cycle of technology and product is shortening and market changes are accelerating, the importance of activities to predict and plan appropriate market entry points after technological development is increasing. In this in this situation, patents are acting as a key means of protecting R&D research and securing competitive advantage, and companies are becoming more inclined to establish strategies that consider patent from the beginning of technology development. Most of the research so far has been focused on the technological roadmap, and patent planning has been relatively neglected. Existing patent-related research is also mainly limited to the trend analysis of existing patents or dispute response strategies, and research planning or predicting future patents is very scarce. Therefore, this study proposes a new concept and process called patent roadmap, which can be viewed as a tool for structurally and temporally predicting and planning patents to be filed in the future based on existing technology roadmap. In addition, this study uses an exploratory approach to predict the future by extracting patents from past data and intends to establish a patent plan through the structure or temporal pattern of patent development. This chapter is the background of the study, which first explains the concept of the technology roadmap and the patent roadmap. The technology roadmap is a strategic market making tool for future technological development and is a method that shows the linkage between products, technologies, and markets in a time series structure. The technology roadmap generally consists of hierarchical structure, nodes and connections and time axis, and can be transformed into various forms depending on the purpose. Recently, not only qualitative techniques but also complex methods combined with quantitative techniques such as text mining are being applied. In addition, the patent roadmap is proposed as an advancement from of the technology roadmap and is a tool for predicting and planning future patents needed to realize the technology. Unlike the patent map, which simply visualize patents, the patent roadmap can be used to establish strategies by reflecting dynamic time flow and feature orientation. A patent is a research of R&D activities and a data source where technical and commercial information is concentrated, which is very useful for analyzing technology trends and identifying competitor strategies. And the analysis method is as follows. Recent research is expanding attempts to quantitatively derive technological progress or promising fields through patent citation network analysis, formal conceptual analysis, and patent valuation models. This paper intended to utilize a multi-facet analysis framework called Tempest And the concept is as follows. Tempest can be effectively used for analyzing and classifying patent development patterns by classifying the various elements that make up the technology. This study proposes a patent roadmap concept and methodology based on technology roadmap, which consists of the technology layer and patent layer. The methodology adopts an exploratory approaches, extracts development patterns based on patent data of similar technologies and applies them to target technology to plan necessary patents in the future. The development of the patent roadmap proceeds in the following steps. I will explain each step in more detail. First, in this study, the concept of technology ontology is applied to decompose the technical elements of the technology roadmap into detailed component levels and organize them. The ontology structures the target technologies and similar technologies in component units, which are the basis for patent analysis and planning. The generated technology ontology plays a role in connecting the technology layer and the patent layer and becomes the basis for comparison of patent development patterns. Based on the technology ontology established in this way, patent data are collected and the keyword vector is generated that indicates whether keywords appear or not for each patent document as 0 or 1. Based on the generated keyword vectors, hierarchically cluster patent documents using cosine similarity. Classify or keywords according to the Tempest classification and link each patent group to the corresponding category. The result is that the patent group Tempest technology ontology is mapped, cl- clarifying the technical role of the patent. To analyze the pattern of patent development, this study applies the Scamper technique and drive both structure and temporal patterns. Scamper is a creative problem-solving tool composed of 7 dot frame to transform existing ideas into new ways, and each item is used a question set to explain the patterns of changes between patents. The figure 4 shows a table in which multiple evaluators scored the fit of the patterns on a 10-point scale for each item in Scamper, and the item with the highest score represents the patterns of change between the patents. Then aggregate the results of the questions to select the best Scamper classification. In addition, development patterns derived from similar technologies are applied to target technologies to plan necessary but not yet filed patents. Based on the planned patent information, the content, order, and expected timing of the patent roadmap are constructed. The illustration provides an example of applying the proposed patent roadmap development method to actual technology. The application target is the transparent AMOLED display, and LCD technology is selected as the technology to be analyzed. In this step, this study builds a technology ontology and connects it with the patent group. First, in the technology ontology construction stage, this study creates an ontology for each of the LCD and transparent AMOLED technologies. Then, 184 keywords representing technical features in each technical field are extracted from the patent document, and the experts filter out necessary keywords. Patent documents are classified into hierarchical clustering based on cosine similarity, and the clustered patents are classified according to the Tempest classification criteria. The patent group classification results are as follows. And table 3 shows the characteristic of patent distribution and the technological focus of each technology field because of grouping patents in RCD and transparent AMOLED technology according to the Tempest classification criteria. In addition, Figure 6 is a visualization of the ontology structure of LCD technology, and the technology composed of TFT panels, driving circuits, and backlighting is hierarchically expressed in units of detailed components. Finally, Figure 7 is a schematic diagram showing the ontology structure of transparent AMOLED technology, and only key technological elements such as transparent TFT arrays and transparent OLED are consciously structured. This step describes the process of planning and predicting the patents required in the technology roadmap through the analysis of patent development patterns. The analysis is conducted in two ways, structural and temporal patterns, and Figure 8 describes the rules for calculating the temporal interval between patent groups. And Table 4 shows the structure patterns of patent development in the LCD technology. It indicates which Tempest classification of patent groups the technology elements are linked to and explains the key linkage structure between technology and patent. And table 5 is also a table of results scored by multiple evaluators for specific patents for each scamper questions and is used to determine which scamper principle is best for each parent change. In this step, a patent roadmap is constructed based on the analyzed structure and temporal patterns, and the process of predicting and planning patents required for transparent AMOLED is explained. And Figure 9 is a visualized illustration of the configuration of the patent roadmap proposed in this study, and the technology layer and the patent layer are expressed together to include the contents of the patent, the order of application, and the expected timing. Each patent is grouped and aligned according to the Tempest classification and predicts the patent development flow of transparent OLED technology. By proposing the concept and construction method of the patent roadmap based on the technology roadmap, this study developed a method for planning and predicting the patent required for the target technology by analyzing the patent development patterns of similar technologies. This not only present the patent roadmap as the basis for the technology roadmap, but also proposes a systematic approach that integrates quantitative analysis techniques such as pattern analysis, text mining, tempest, and scamper. In addition, this study has implications that it is possible to establish strategic patent plans for promising technology areas and use them based data is for resource allocation and policy establishment. However, since the study derived patents based on one technology, verification of various technologies is required and further review by technological experts is required during keyword extraction and patent interpretation. It can be expanded to a structure that reflects the strategy, capabilities, and market environment of individual companies and can design patent roadmap in various formats to meet various purpose and user needs. If these are improved, the patent roadmap can be developed as strategic tools to connect technologies and market and drive commercial success of R&D. This is the end of the review presentation. Thank you.